All right, today we're going to finish section 2. So yesterday we talked about inductive reasoning, right? Which inductive reasoning, we looked at clues to figure out a pattern. Yes? Okay, so on deductive reasoning, we're going to use facts, definitions, properties, any of those things to help us form a logical argument. Okay, so deductive reasoning, our first definition. Uses facts, definitions, properties, and the laws of logic to form a logical argument. Okay, so law of logic number 1 is called the law of detachment. It says that if a conditional statement is true, then it must be true for specific cases. Okay, so our first example is, if you live in Houston, then you live in Texas. Okay, it says Bob lives in Houston, so what is our conclusion? Bob lives in Texas, right? Okay, example 2 tells us if a triangle is isosceles, does anyone remember what isosceles means?
Yeah. Two congruent.
Yeah, which it tells you in the following part of that sentence, right? Then it has two congruent sides, okay? So if triangle ABC is isosceles, what is our conclusion? Two congruent sides, good. Triangle ABC has two congruent sides. Okay, these are pretty straightforward, yes?
Yeah.
All right. Law of detachment is a little more simple. Okay, on the back page, our second law of logic is called the law of syllogism. It says when two true conditional statements lead to a final conclusive statement. I can't spell today. So, example 1 says, if you study, then you make good grades. If you make good grades, then your parents will be happy, right? So, what could our conclusion be?
If your parents are happy, you're happy.
If your parents are happy, your parents will be happy. If you get good grades.
So really, we can just take this first part, right? If you study, then what's going to happen? Your parents are going to be happy, right? Because notice how they kind of wrote the same thing twice, if you make good grades. So essentially, law of syllogism, we cut out what has been repeated and we put the other parts together. Okay, so our conclusion is going to be, if you study, then your parents will be happy. Yes. Okay. All right. So on our second part, it says if x squared is greater than 25, then x squared must be greater than 20. If x is greater than 5, then x squared is greater than 25. So what parts do we have here that we could get rid of? Yeah, this x squared greater than 25. So on our first part, our hypothesis was this, right? And our final conclusion was here. So we can get rid of those, and then how could I write this?
If x is greater than 5, then x squared is greater.
Good. If x is greater than 5, then x squared must be greater than 20. Right? And this should make sense to us because choose a number greater than 5. 6, what's 6 squared? 36. Anything I choose over that's going to keep giving me bigger numbers, which are going to be greater than 20. Okay? All right. Anybody want to try number 3? Number 3 says, if a polygon is regular, then its angles are congruent. If a polygon is regular, then its sides are congruent.
Can you just say it's congruent? Like if the polygon is regular, then it's congruent?
So here's where you have to be careful. Like, let's say we get rid of. So here's kind of the hard part here, right? We kind of have two hypotheses. Hypothesis. Okay. Let's say we got rid of both of those and we put this together. Does it make sense to say if angles are congruent, then the sides are congruent? Not necessarily, because we don't know that that's true. Okay, so this is one of those cases, which won't happen a lot, but we don't have a conclusion here. Okay. All right, last part, we're just going to go through real quick, inductive versus deductive. Now remember, inductive reasoning was based off patterns. Deductive is based off what? Facts. That's how we can tell the difference. Okay? So, all we're going to do is decide if we're going to use inductive or deductive reasoning. If it's deductive, we're going to say which law we're going to use. Okay? So, example 1 says, I got up at 9 o'clock for the past week. I will get up at 9 o'clock tomorrow. Fact or pattern? Inductive, right? Because is it a fact that I will 100% get up at 9 tomorrow? No, right? What could happen? My alarm doesn't go off. I oversleep. I hit the snooze. Okay, so that's going to be inductive reasoning. No, we know it. Okay. Example 2. All dogs have ears. Golden retrievers are dogs. Therefore, they have ears. Deductive reasoning. And which one would this be? True, which one? Detachment or syllogism? Detachment, yeah.
Yeah, that's one I look at.
Yeah, I gotcha. The easiest way to tell a syllogism is if it repeats something twice, right? Okay, example 3. Every even number is divisible by 2. 1986 is an even number. It is divisible by 2. It is deductive, right? Those things are fact. What law would we use here? Yeah, which one? Detachment or syllogism?
Syllogism.
Joss? Did you say no? Huh? I thought you said no. Was that not you? Who said no? Oh, yeah. So if it's not syllogism, what does it have to be? Detachment, right? Okay. All right. Example 4. If you wear school colors, then you have school spirit. If you have school spirit, then you feel great. If you wear school colors, then you feel great. Okay? Now, this looks like the examples we just did before, right? So this is deductive reasoning, okay? Even though technically I wouldn't call this fact, but it does have that part where it says, then you have school spirit. If you have school spirit, then you feel great. Well, then what they do for our final conclusion, they cut that part out. So this would be syllogism. Okay. All right, last one. In the sequence 1, 2, 4, 7, 11, 16, the next most probable number is 22. Inductive, right? Because we're looking at a pattern. What's our pattern here?